welcome to the first day of your second unit. We will be talking about something called vectors, okay? Today we'll be defining and graphing vectors. We'll convert vectors to something called component form and then graph, and then we'll discuss magnitude and direction at the end of the lesson. Your warm-up is a review of order of operations. So remember, that is what we sometimes refer to as PEMDAS. Parentheses, exponent, multiply, divide, add, and subtract. So take a moment now to pause and try the warm-up on your own. 1A, we have multiplication first. So we'll have 7 plus 18 minus 2. Then we will simply add and subtract from left to right. Okay, 7 plus 18 is 25. 25 minus 2 is 23. 1B is the same numbers, but they've added parentheses, so we have to add 7 plus 6 first to get 13. Okay, and 3 minus 2, which is 1. So 13 times 1 will be 13. So when we add parentheses to a problem, obviously it makes it a different answer. So this is going to be very important throughout this unit. Okay, one more time to emphasize, multiplication first if there's no parentheses. So I'll have negative 5 plus 16 minus 4, and then going from left to right, that would end up with 7. But if we add parentheses, that means we're combining negative 5 with negative 8. So that will be negative 13. Multiplying it times negative 6 from that negative 2 minus 4. And negative 13 times negative 6 is the very different positive 78. All right, so PEMDAS. Yes, it is important. Parentheses, exponents, multiply, divide, add, and subtract from left to right. So here are our initial notes. Okay, now these initial notes, of course, will be very useful to write down because they are definitions. If you need more time writing, this would be a great time to pause the video. Our notes have to do with what is a vector. A vector is a value that has both magnitude and direction. Okay, so far we've only worked with numbers with magnitude, which makes a lot of sense because that's how much of something, but where it's going matters too. Okay, it can also be called the directed line segment, and it's indicated by PQ. And you'll notice that PQ has a little line over its head. Okay, so if you were to emphasize that, the way you write it is literally PQ, and that is not an accident. Okay, that symbol means PQ is a vector, and it is important to note that the direction of the arrow in the order of letters is important. We are going from left to right, from point P to point Q. Again, emphasize our next point. It has initial point P and terminal, aka end point Q. There's a special way to write its magnitude or length, which we'll be finding tomorrow, and that's PQ, and we put it in 2 bars around it. All right. Another important thing is sometimes, because people are lazy, we have a different way of writing vectors, which is bold lowercase letters. So I can say bold V equals PQ. I'm aware that when we write in pencil or pen, it's a little hard to make it bold. So instead of just doing the casual V, you could do some emphasis by coloring in some extra V. Other common letters you will see indicating vectors are P, aside from the PQ format, is V, W, and bold U, which I can never make pretty, but some people have more skills than I, so bold U. All right, again, pause if you need more time on your notes. All right, so to graph a vector is not terrible, okay? So this is on the worksheet I have given you, okay? If you will look at number 1, the first thing we will plot is point P, okay? And I will do that in green. So point P, remember it is X and then Y, right? My Y. Oh, that's ugly. Y. Okay, so x is first, -3 is over here to the left, and -4 is down. So there is my point P. Please note I did a little green dot. Okay, so there's point P. And then point Q, okay, which I'm going to do in red, okay, for begin and end. Okay, my Q is at 1, 2, so that means I will be going right 1 and up 2. Now this does not a vector make because that is just 2 points. If you recall on our previous slide, it said it's a directed line segment, starting at P and ending at Q. So our directed line segment will go from P to Q. So what you do is you connect P to Q, but to indicate that Q was second, you add an arrow. Now theoretically you will draw as straight as line as possible. This is my ability, okay? The idea is if we labeled it, it is now correct, okay? So take a moment to pause here and do 1, 2, 3, and 4 on that worksheet. Make sure you're making sure that P is your point where you start with and Q will be the arrow direction that you are going. There is a YouTube video that is not mine about vectors that I strongly suggest you watch because it is interesting. It is linked on Google Classroom. All right, so component form of vectors. So we like P and Q very much when we're given a point 1 and 2 to start with, right? But you remember at the very first notes we said sometimes we write them as bold letters, right? Basically what that is called a component form. And a component form is instead of taking your vector as it's given, okay, we're going to make it into this. And what the whole purpose of a component form is it starts the vector on the origin. Okay, so instead of having a vector just floating out in space somewhere, we instead make it so that the origin of the graph, 0, 0, is always going to be our beginning. That way we can work with more than one vector at a time easily. Okay? So if I'm looking for, all right, so let's see how it's done. So number 1, it's asking us to find bold V, and they've given us P 8, -1, and Q 3, 1. So what I'm going to do is work with my X's first. Okay, and you'll notice that I'm always going to put the second X first. It is very important. Okay, so look at our formula, X2 minus X1. So X2 is 3, and I'll subtract 8. So the X value of my component form should be 3 minus 8, which is -5. Okay, then I'm going to deal with my Y's, and again, it has to be the second one minus the first one, okay? Second Y minus first Y, so that will be 1 minus -1. And I know everyone loves the minus. 1 minus -1 is really 1 plus 1, which is 2. So my bold V, the answer of the component form, is -5, 2. Now, did anyone notice my brackets? Okay, they are not parentheses, they are little pointy arrows. They're not quite a full arrow, but they're not a parentheses either. That's how I know that they're in component form, okay? Points will have nice smooth parentheses, points parentheses, see? And vectors will have sharp brackets. All right, let's look at number 2. Okay, number 2 is the same process. Make sure you're taking your X's first, and we're going to do the second X, which is 5, and subtract 2. 5 minus 2 is 3. Okay? And then we're going to do it again for the Y's. Second Y first. 3 minus 2 is 1. Put it in the brackets. You are done. So you can write bold U. If you struggle with the bold, you can always do vector U like that. Okay. Last but not least, let's do number 3 in case you need one more example. Now this one is tricky with the zeros. Just because there's zeros does not mean we're going to disobey our rules. Second one first. 3 minus 0. What is 3 minus 0? That would be 3. And then our next one, okay, with our y's, okay, that'll be 1 minus 0, and that is 1. It is very important to always go second point, your terminal point first, okay? Subtract from the terminal. That will make sure that your vector ends up going in the correct direction. All right, so to finish your classwork, if you already finished the graphing, okay, you're going to do 5 through 10, finding your component forms. And then 11 and 12 is a little tricky, okay? So I'm going to go through number 11. Now on number 11, we already had our original one on number 1. Let's put that back on there, -3, -4. And then we had Q. And Q's at 1, 2. And we put our vector on. All right, so if I find the component form of number 1, right, that will be 1 minus -3, which is 4, comma, and then I will have my y's, 2 minus -4, which is 6. So that's my component form. So if I were to go back and regraph that onto number 1, okay, what that will look like is I start at the origin for my new point, and I go up 4 and over 6. Oh, did I do that backwards? Yes, I did. X. So right 4 and up 6. Don't make that mistake. It's very common. And what you should notice is these are not parallel. Okay, they are the same. So it is like taking a stamp and reprinting your vector from wherever it was to be on the origin. They are not connected. They are the same but in different places. All right, do your best on the classwork. I believe in you. Let me know if you have any questions.